Welcome to The Explainer. Today, we are diving into something that's a pretty big deal in the world of AI. It's a fundamental shift in how machines see and understand the world around them, moving from predicting specific words to predicting pure meaning. We're talking about a new model from Meta called VL-JEPA, and honestly, it could change everything. Okay, here's what we're going to cover. First, we'll dig into the big prediction problem that's been holding AI back. Then, we'll look at a totally new way of thinking, in ideas, not words, that's flipping the script. We'll properly meet the model making it happen, VL-JEPA, and look at the proof that it's actually smarter and faster. After that, we'll explore the real-world payoff and wrap up by asking the big question, what's next for AI? So let's start with the why. Why do we even need a new approach for vision AI? I mean, aren't today's models already kind of amazing? And yeah, they absolutely are, but they have a pretty big secret. And that secret is that they're often incredibly inefficient. You see, they can be super expensive to train. They eat up a ton of resources, and they have this built-in lag. Now, for some things, a little delay is no big deal. But for technologies that need to react in an instant, think smart glasses or robotics, that latency is a total deal breaker. It's been a major roadblock. This right here is the root cause of that inefficiency. Most models today generate text auto-regressively. It's a fancy term, but what it really means is they generate one single word at a time. They predict the next word, then the next, and so on. This forces them to waste a ton of energy modeling not just the core meaning of an image, but all the tiny, irrelevant details of language, like phrasing and style. It's very thorough, but it's also painfully slow and wasteful. So, if the old way is too slow, what's the alternative? Well, this leads to a completely different way of thinking about AI prediction. What if you could just skip that whole laborious word-by-word process? This question is really the aha moment behind all this research. What if, instead of trying to nail the exact right sentence, an AI could just get the gist of a scene? You know, understand the core concept first, and then worry about finding the right words later. This slide just lays out the whole philosophical shift perfectly. On the left, you've got the old way, predicting in token space. It's like building a sculpture grain by grain. But on the right, you have the new way, predicting meaning in embedding space. This is an abstract world of ideas. It's more like a concept artist who sketches the essence of the entire scene, the mood, the action, all at once. By focusing only on what actually matters, the whole learning process becomes so much more efficient. So let's meet the model that actually puts this new approach into practice. It's called VL-JEPA, which is short for Vision Language Joint Embedding Predictive Architecture. Now, I know this diagram looks a little complicated, but the core idea is really simple. On the left, the system takes in some kind of visual input, like a video clip. Its main job isn't to spit out a sentence, its job is to predict a target embedding, which is that abstract representation of meaning we were just talking about. That is the key difference. And as we're about to see, it's a system with 4 key parts that all work together. Okay, here's the breakdown. The X encoder sees the world. The Y encoder understands the meaning of the target text. The predictor's job is to learn how to connect what it sees to what it means. And then finally, way at the end, there's a Y decoder. But here's the most important part. That decoder is a tiny, lightweight piece of the puzzle that's only used when you absolutely need a human to read a sentence. All the heavy lifting is already done. All right, so this new method sounds good in theory, but does it actually perform better in the real world? Well, the data is pretty convincing. In a direct head-to-head comparison with a standard model that predicts tokens, the results are just crystal clear. If you look at these charts, you'll see VL-JEPA's performance is the blue line, and the traditional model is in red. For both video captioning on the left and classification on the right, that blue line just shoots up. It learns faster, and it performs better, plain and simple, using the exact same amount of data. And it does all of this while being way leaner. Because it isn't bogged down trying to predict exact words during training, it has half the number of trainable parameters as the traditional model it was up against. That just makes it much more efficient to build and train from the get-go. And that efficiency has a massive payoff when it comes to speed. Just look at the bar charts on the right. You can see the comparison of trainable parameters and something called inference time. Because that text-generating part is separate and lightweight, the model can do tasks like finding information way faster, since it doesn't always have to go through the slow process of writing a whole sentence. This is what makes it so powerful for real-world use. So what does all this efficiency actually let us do? This is where it gets really exciting, especially for anything involving live video. This is all possible because of a super powerful concept called selective decoding. Since VL-JEPA is spitting out this constant stream of meaning, it doesn't have to describe every single frame of a video. Instead, it can just intelligently monitor that stream of meaning and decide to generate text only when something important changes. The chart on the right shows that this method gets the same performance while saving a huge amount of computational power. So what's the result? Well, to get the same quality of information from a live video stream, VL-JEPA needs to generate text almost 3 times less often than a model that just decodes at a constant rate. That makes it absolutely perfect for things like real-time action tracking in smart glasses. And it's not just about speed. This architecture is incredibly versatile. It creates a single, unified model that can handle a whole range of tasks, from classification and retrieval to answering questions, all without needing specialized tweaks or totally different architectures for every single job. Okay, so let's zoom out for a second. What does all this mean for the big picture of artificial intelligence? This feels like more than just a new model. And this quote from the researchers really gets to the heart of the innovation. By shifting from the world of separate words or tokens to this continuous space of meaning, the AI's job becomes fundamentally simpler. It isn't distracted by linguistic fluff. It can predict the core idea all at once. This isn't just a small step forward. It's a genuine paradigm shift in how we teach AI to understand our world. Which leaves us with a pretty fascinating final thought. For years, we've been building bigger and bigger models to process more and more words, faster and faster. But maybe the real path to more capable, more efficient, and maybe even more truly intelligent AI systems isn't about processing more words, but about better understanding the ideas behind them.